Hello, welcome to Tensar Ground Coffee. A few minutes on ground engineering to enjoy while having your coffee. This time I want to talk about the different terms related to settlement. Uniform settlement, differential settlement and curvature. And what is the distinction between those and which of those really matter when it comes to setting criteria for damage to buildings and highway pavements. So let's explain those three terms. Right, Brian, over to the flip chart. So let's look at the case of building settlement and highway pavement settlement. So we have a building like that on a spread foundation. There's the ground level. It has settled that much, but all by the same amount. So that is uniform settlement. And a highway pavement, let's do that again. A highway pavement, if the soil settled uniformly, there'll be no sign of that settlement on the highway pavement except for the fact that the level has dropped. It will not cause any damage because everything is moving down the same. So that is uniform settlement. Next, we come to differential settlement. And this is what is often quoted in specifications as a performance criterion. So here we have a building that has settled again, but this time not in a uniform way. It has settled more on this side than it has on this side. So that is a differential settlement. And that can be expressed as a slope. You see there. But if it is a constant slope, that will not directly cause damage to the building because there's no distress being felt by the building. Clearly there is some tilt, so when the differential settlement gets to a certain level, the tilt will be visible and that will be unacceptable. And there may be some machinery within the building that does not function correctly when there is too much tilt. The same goes for a highway. If we got differential settlement of a highway pavement, that's not going to cause any damage to the pavement surface on its own. You might lose some of the falls for drainage, so the water might flow in the wrong direction if it gets too big, but that's not going to cause damage to the pavement. So that is called differential settlement. Finally, we come to curvature, which is caused by a change in the slope of settlement. So let's imagine that the building foundation settles, but in a curved way so that the slope is changing as we go across the building. That's going to cause distortions in the building that create tensile strains that cannot be sustained by certain materials such as masonry and brickwork. So that is going to cause the damage and the cracks in the building. The same goes for a pavement. If the pavement has a low curvature like that, it may be able to sustain that okay. But if it has a higher curvature, exaggerated there, that is going to quite likely cause cracking and damage in that highway pavement surface. So it is really the curvature or the change in slope that we want to avoid, because that's what causes the damage. And we measure that. Let's take this example. If we drew a straight line across there, that distance there is the deflection delta, and we have that length there is L, so that is expressed as the deflection ratio delta over L. That is one way to express the curvature or the amount that the slope is changing. So if you want to avoid damage to a pavement or a building, you really need to focus on this measurement of the settlement rather than the others. Okay, that's all for this episode of Tensile Ground Coffee. Thanks for watching and see you next time.